Hello, everybody. We're going to start our talk about the state of pgRouting. And let me introduce myself. I am Vicky Vergara. If you see one of these icons, me with my doll, she's here. Wait. There she is. Or a chess piece. Those are the icons that I use on the internet. And we're going to be thanking ahead of time to Claudia Dragoste. Did I pronounce it? She's going to be helping me in this presentation. So let's give her a big clap because she's my volunteer. As you know, pgRouting projects work like probably 50% of the time with volunteers. And the rest of us are basically somehow being paid, or there is some income there because we also have to eat. So right now she's a volunteer. You can find pgRouting code on GitHub. You just go to github.com, pgRouting. And what is pgRouting? pgRouting is an open source library that it's based on a PostGIS-enabled database from Postgres. That's how you get pgRouting. That basically, with the name you know that it can do routing, but it can do more than that. Ready?
Okay, interrupting this presentation to give the following breaking news. On November 2024, the pgRouting version 3.7.0 was released. We thank Rajat, Regina, Josefa, Ashish, and Vicky for the effort. And now we go back to the presentation.
So, what are we going to be doing today? We're going to be tackling a problem that comes from the Sustainable Development Goals from the UN. In this case, we're going to tackle a problem in this area that ensures access to affordable, reliable, sustainable, and modern energy for all. So, what is this goal that we're going to be having? We're going to have a small map, and we want to distribute electricity, but the main lines only, you know, the ones that have the high voltage. So we're going to be using pgRouting not to route cars. We're going to use it for another task that doesn't involve cars. Okay? We're going to try to minimize the length of the cables, and to do that, we're going to be using pgRouting. If you want to try it, all these instructions are located on the pgRouting workshop in the advanced section. I will be flying through, but the workshop has more detailed explanation on what these instructions are doing and what is the purpose. So first we're going to be downloading from OSGeo download page the Mumbai.osmbz2. It's a snapshot of Mumbai in a very, very small area because it's just a small exercise. And we're going to unzip that information. Once we have it unzipped, we're going to be using one of pgRouting products that is OSM to pgRouting to import it to the database. We're going to be using a map configuration for roads, and we're going to be using the schema roads on the database named Mumbai. This is using OSGeo Live, where the user is user and the password is user. And we're going to prefix all our tables with the prefix roads. We're going to import all the tags, and we're going to work on a clean database.
Interrupting this presentation to give the following breaking news. OSM2 pgRouting is used to import OSM data to the pgRouting enabled database. The plan for OSM2 pgRouting is to enhance the code with a focus of not only importing OSM format, but also to import PBF and O5M. And now we go back to the presentation.
So, we're going to be first creating a vertices table. A graph, theoretically, it's a set of edges and a set of vertices. So, to be able to use more functionality of the pgRouting extension, we need to have somehow the vertices table. And we're going to fill up the vertices table with additional information that are not in graph theory, okay? So the first thing we're going to be doing is we're going to select into a vertices table the results of the extracting the vertices from our edges, which is in the function pgr extract vertices. Sorry, and no, not yet. And filling up the function, graph theory doesn't include any geometry at all, but we are interested in the geometry, so we're going to be filling the geometry information of the segments, and we're going to be also filling up the XY values, because there are some functions in pgRouting like pgRA star that use this information.
Interrupting the presentation to give the following breaking news. pgr extract vertices is the function since 3.3 to help on the creation of a vertex table. You can find it in the documentation. We also let you know that pgr create vertices table will be deprecated soon. And now we go back to the presentation.
Thank you. So, now that we have our vertices and our edges, the tables created on the database, we're going to add to both tables a column that is named component. And we're going to fill up the component column first on the vertices table using a pgRouting function. And then we're going to fill up the edges table using the results that are stored on the vertices table. How do we add a column in a table? We alter the table and we say add column and the name of the column and the type of it. So we're adding it to the edges table, which is roads, ways, and to the vertices table, which is roads, vertices. And we're going to update first the roads vertices to set the component. And we're going to be using that as with pgr connected components. That function, we could use another function that could be strong components. We have several functions that are related with a component. Now, maybe you might be asking yourself, what is a component? You have a graph, but it might be disconnected. Maybe it has two subgraphs that are not connected at all, those two are two components of the whole graph. So we cannot route or do anything connecting two that are disconnected because there is no information about that connection, okay? And, oh, sorry. And also, yeah, maybe it comes later.
Interrupting the presentation to give the following breaking news. I have to stop it. Back with the news. pgR connected component is a function that analyzes the network to detect in how the graph is connected, disconnected. Is part of the component family of functions. And now we go back to the presentation.
So once we have the component column filled up on the vertices table, we're going to use that information to set up the component number of the edge. Okay, so pgR connected components is a function that the result is given in terms of vertices. That's a need. That's one of the reasons we need a vertices table to save that information. Remember, graphs are edges and vertices. So what can we do with those disconnected components? For this very simple exercise, what we're going to be doing is we're just going to delete everything that is not on the main big component of the graph. But depending on your problem, you might go back to your data and finish up filling up whatever is needed. So this is a very large function where we're saying these are my components. I want to count how many rows are in that component, get the component that has the maximum count, and then at the end we're going to delete everything that is not on that component. So if we have a component that has 1,000,000 rows, we're going to delete all the other components. And this is deleting them from the roadways. And this one is just a small change. You could see that basically nothing changed. This one is deleting it from the vertices table. So the work on both tables in this case is very similar. And once we have our data cleaned and reviewed, there are many functions that analyze a graph besides the components. We are going to proceed to get the minimum spanning tree, which is theoretically the best result for our graph to lay these electricity cables. For that, we're going to be using prepare edges as. Normally we use a select statement, but right now I want to save that select statement in a prepared statement. And we're going to be using cross-call, which is one of the minimum spanning tree functions that we have. We have the cross-call algorithm, we have the prim algorithm, and we're going to be using the depth first search, because we can also be using a breadth first search. Okay?
Interrupting the presentation to give the following breaking news. Top secret. pgRouting inner queries can also be prepared statement. Instead of using the select clause, use the prepared statement name. And now, go back to the presentation.
Thank you. So the result with our small Mumbai data would be that one. We could think also a similar problem is like where the school is closer to which streets. There can be many problems that are similar, that the process might be similar, and you're solving a completely different real-life problem.
Interrupting the presentation to give the following breaking news. Planning to release pgRouting version 4.00 before June 2025. And now we go back to the presentation.
Thank you. So let me talk, just to wrap up, talk about pgRouting ecosystem. We have pgRouting, which is our main project. This project is the one that it's an OSGeo project. Everything around it is just a sub-product that is needed for making this work, but any other sub-product is not part of the OSGeo project, only pgRouting. We also have a repository named VRP Routing, which solves vehicle routing problems. Those are problems that involve more than one vehicle, and those are vehicle focused. Like you have a fleet of Ubers and you want to do pickups and drop-offs. This helps to solve those kinds of problems. We also have the pgRouting workshop. So everything we saw about this SDG number 7, it's on the pgRouting workshop. It's a demonstration that the software that you are using, it's also can be used to solve any problem, real life problem of our own communities. Not necessarily OSGeo community, but where we live. We also have OSM to pgRouting, which we talked during this presentation. And we have pgRouting layer, which allows you to do some simple, very simple queries. Because when you're really using pgRouting, you have queries within queries, and it's an inner query. You have to clean up the graph. So it's not, it's just to make something very simple. This one is about transportation. There is also standard data for transportation, and we're starting to work on this. It's on diapers. And we also have the pgRouting book by Regina Obe that you can get. It's Locate Press. And we want to thank our gold sponsor, OSGeo UK, for the sponsoring that it's been doing for the last years. And please, if you have donations, you can go to Open Collective to donate to the project. And please keep routing. A big thanks to our weather girl.